This is today's Leetcode problem called valid perfect square. And so basically what it says is that you're given a positive integer, a number, and you basically have to tell if the number is a perfect square or not. So return true if the number is a perfect square, or return false if it's not. And it says specifically not to use any built-in function, squared for C++ and other stuff, I think. So example 1, the input 16. 16 is a perfect square, so it should give true. 14 is not a perfect square, so it should give false. Okay, so um, it's just a Boolean function, and you have to give and it's given the parameter as a integer variable called num, and you have to basically return true if perfect square, or return false if not. And that's it. So I'll be going to the whiteboard to show you the method how to do this. Okay, so how do we actually try to solve this problem? So let's think of some basic test cases. So we have 1 squared, which is equal to 1, 2 squared is equal to 4, 3 squared is equal to 9, 4 squared is equal to 16, and 5 squared is equal to 25. Right? Our program should say this is a perfect square, perfect square, perfect square, perfect square, perfect square. If you give something like 14, it's not a perfect square, right? So there's actually a very simple formula. There's actually a simple pattern in this. So the difference between 1 and 3 is plus 3. Here it's plus 5. Here it's plus 7. And here's plus 9. So basically it's an addition of consecutive odd numbers, and I'll try to show you visually how that's done. So let's take, here we have 1x, and then you put 1, 2, 3, that's still a square. Put 1, 2, 3, 4, 5, that's still a square. So now we have 1, 2, 3, 4, 5, 6, 7, 8, 9, so it's a square. And then you add 1, 2, 3, 4, 5, 6, 7, that's still a square. It's a square of 16, so 4 times 4. And then we add another 9, 1, 2, 3, 4, 5, 6, 7, 8, 9, that's still a square. So now this is a square of 5 times 5, which is 25. So the formula goes, any perfect square is made up of consecutive odd numbers being added to each other starting from 1. So let's take 1. 1 is equal to 1, and then uh, you say 2 squared is equal to 4. What is 4? 4 is 1 plus 3. You say 3 squared is equal to 9, and what is 9? 9 is 1 plus 3 plus 5. 4 squared is equal to 16. What is 16? 16 is 1 plus 3 plus 5 plus 7, and it goes on. So this is a formula that we use to find if it's a valid perfect square or not, and this should be very simple to code. So what we can do to code this is so let's go back to 9. 9 is equal to 1 plus 3 plus 5. What is 10? 10 is 1 plus 3 plus 5 plus 1. So it's not consecutive odd integers here, right? So like a different way we can think about it is by saying, why don't we start at 9 and subtract by a factor, and the factor is an odd number, which initially the factor is equal to 1, and the factor increases itself by 2 to get to the next odd integer, the next consecutive odd integer. So first it goes 9. 9 minus 1 is equal to 8. 8 minus 3 is equal to 5. 5 minus 5 is equal to 0. And then we can see that if it's a 0, if it ends in a 0, that means that you subtracted by odd consecutive numbers starting from 1, which means that this is a perfect square. So let's try 10. 10 minus 1 is equal to 9. 9 minus 3 is equal to 6. 6 minus 5 is equal to 1. 1 minus 7, because 5 plus 2, the factor will be added by 2 to go to the next odd number. So 1 minus 7 is equal to negative 6. Negative 6 is not equal to 0, so that means that will not be a perfect square. Let's try 16. 16 is equal to 16 minus 1, or sorry, 16 minus 1 is equal to 15. 15 minus 3 is equal to 12. 12 minus 5 is equal to 7. 7 minus 7 is equal to 0. This is 0. So that means that is it. That is a perfect square. And this is not. Just for one more, we can try 14. 14 minus 1 is 13. 13 minus 3 is 10. 10 minus 5 is 5. And 5 minus 7 is negative 2, which is not a 0. So that's not a perfect square. So using this formula, you can see that it's actually very simple code-wise to actually code this up and find the solution to this problem. So I recommend that you code it yourself, but I will also be showing this in this video. So I'm gonna be doing it in C++, but you can do it anything, any language, it doesn't matter. So first, what we said is that we want to create a factor variable so that we can so that we can subtract the original number by that factor each time to see if it is a perfect square or not. So we can create an integer factor, and you can set that to 1 because you want to start at 1. And then so basically what you had to do is that you have to do a while loop, and you had to say while the number is greater than 0, because remember we're going to do num is equal to num minus factor. So if the number is if the number is originally if the number is like originally 9, then 9 minus the factor will become 1 is equal to 8, right? And then we want to say after that happens, we want to say factor is equal to factor plus 2. So we want to increase the factor, and then now when it goes to the while loop again, it will say 8 minus 3 is equal to 5. And then it keep doing this until the number becomes 0 or less than 0. So instead of saying 0 less than 0, we can just say while num is greater than 0. It's the same thing as saying is while it's not less than 0 and it's not equal to 0. So while the number is greater than 0, we want to subtract the number. So we want to set the number is equal to num minus a factor. And then so originally the factor is 1, and now we say, and then so then the first time it comes to the loop, it'll subtract the number by 1, and then we want to increment the factor by 2. Factor is equal to factor plus 2. And then what this does is that it just increments the factor variable from 1 to 3, 3 to 5, and so on. So when this comes here, num is equal to num minus factor. And then when it breaks out of the while loop, when it comes out of the while loop, you'll know that the number is either 0 or less than 0. So remember we said that if it's 0, that means it's a perfect square, and if it's not 0, that means it's not a perfect square. So you can say if num is equal to 0, then you just return true. Return true because it's a Boolean function and it wants to return true. And return true means it is a perfect square. You can say else return false. And so this is the code. So it's actually very simple. I'll just make some quick changes. You actually don't need this else here. You're gonna say return false because it'll automatically exit the function when if this comes here. And then you can say num, instead of saying num equals num minus factor, you can just say num minus equals factor. And then factor plus equals 2. It's just saying factor is equal to factor plus 2. Yeah, so now this should be the code, and let's see if it runs for the input test case. Yes, it worked for this, so now let's try submitting it. It got accepted. So this is it. So it was actually a very simple problem, but I think it's a good problem for many to understand how we got to the understanding of how to do this valid perfect square. Thank you for watching.